Hi everyone. Hi everyone. Today we're going to be going through some logarithmic um, differentiation. This is also in combination with hyperbolic differentiation. Sorry. I've done a few examples over here. There's also the theory of hyperbolic functions as well. But I'll make a separate video on that today. I wanted to do this first question on how we can differentiate this term over here. Requires a few steps, but it should be relatively simple. Let's just put this in terms of y. So let y equal to 2 to the power of sine x. Okay. When we're differentiating something, it's really important that we are looking for shortcuts. I think that really helps because I think differentiation is not hard. However, with crazy, wacky terms, you need to simplify or break it up into problems. And usually with differentiation, it's easy because differentiation is a linear operator. So what that means is to differentiate a whole term, you can split that term into many terms of additions or minuses and differentiate each term respectively and then add them together to calculate the differentiation of the whole term. So it's a little bit of a hard explanation that I've given you, but hope that makes sense. Okay, immediately, this is looking a little bit wacky, right? There's I guess our main bit is at the top. So I'm going to do a neat handy trick, and that is to put everything in terms of logarithms. So I'm going to put this in logarithms y. Remember, once you do something to one side, you have to do to the other. So I've just actually converted that into a logarithm. That's the first step, okay? Second step is I'm going to simplify. So sine x 2. The reason why I can do that is because of our logarithm laws where you can bring a power out to the front. So it's very, very simple. This is literally high school maths. Okay, so we have our term over here. I want us to realize that this is a constant. That just makes things a little simple. Let's start differentiating. So we're going to put this, let's use orange. You can bring the constant to the front. Okay. So this is a little bit of a different term. We're going to use the chain rule. This is called implicit differentiation, where you're differentiating a different term implicitly. So in this case, to find the derivative of this, we're going to let u equal to y. So it's going to be 1 on y multiplied by dy dx. And that's how you calculate it. Then you get, dy dx is equal to times 1 on y is equal to 2 times, so the derivative of sine x is cos x. Okay, easy. And hence y times is equal to dy dx. Notice that y over here is actually equal to this bit at the front start, so we can use that. Let's sub that in. So our final answer is Just going to write that one more time in a different colour. And that's our final answer. Thanks for listening.